So here's the problem for this video. You're supposed to find the second partial derivatives of the expression z equal 3xy squared minus 2y plus 5x squared y squared, and then determine the value of the mixed partial here, z sub xy evaluated minus 1 and 2. So we're looking at partial derivatives. If you can do regular derivatives, you can do partial derivatives. Now your standard functions say y equal f of x. For the first derivative, we can say y prime derivative. So since y and f of x are the same, we can find f prime derivative of f prime and then evaluate. We can use this notation, dy over dx. We can use the operator notation, d sub x derivative of the function over here, and then you put it right there, whatever you want. Now for partial derivatives, we're dealing with expressions of two or more variables. In this case, it's a function x of x and y. It could be x, y, and z. So here we have z is a function then of the variables x and y. And this is the notation you use. Partial derivative of f with respect to x is the same thing as f sub x. If you're using z to denote the function, z sub x means the same thing, partial derivative of z with respect to x. You can write it this way. Same thing, partial derivative of z with respect to x. Partial derivative of the function f of xy, x comma y, or we can use the last one. F sub x of xy means the derivative with respect to x, and then you have it for, say, the other variable, same thing. Partial of f with respect to y. Second one means the same thing, partial of f with respect to y. Partial of z with respect to y. Another way, partial of z with respect to y. Partial of the function of xy with respect to y. And then the last one here, f sub y of x comma y. Those are all notations for the same thing, partial derivative. My favorite, if I'm taking the derivative with respect to x, is to write z sub x. Or if I'm using f sub x means the same thing. This notation here is more cumbersome. Same thing with this one, but those are other ways to express it. And then you have the same thing for y. Partial of f with respect to y. F sub y means the same thing. Z sub y means the same thing. All of those represent the same thing. And then the first partials evaluated at the point a, b are denoted by, just like regular derivatives, you can take a derivative, first derivative or second derivative, and evaluate it. So this means the derivative of f with respect to x evaluated at some point a, b, or derivative of f with respect to y evaluated at a, b. And you can use these other notations too. But those are the ones that I would use. Easier to write out. So let's get back to the problem. Now again, when you're working with partial derivatives, you're still pretty much going to use the same formulas. But here's what you have to do. This one says find the second partial derivatives of z equal 3xy squared minus 2y plus 5x squared y squared. And then determine the value of the mixed partial. This is z sub xy. It could be z sub yx at this value. So we want the second partials. Just like in regular derivatives, you want the second derivative. First you have to find the first one, y prime. Then take the derivative of that. So in this case, got to find the ball. So I'm going to use z sub x equals. Now look over here. Got x, variable x, and y. So if you're taking the derivative of some function or some expression with respect to x, all you have to do is treat the y like a constant. Treat y like a constant. So if you have a plus y over here, add it. Derivative of constant is 0. This would just go to 0 when you take the derivative with respect to x. So here's the way it works. Again, we're going to find the first partial. So that means over here, wherever you have a y, treat it like a number, constant. So the derivative of 3x y squared with respect to x, that would just be 3y squared. The derivative of minus 2y, y remember is supposed to be a constant. If you're taking the derivative with respect to x, all the other variables are constant. Because you could have more than two variables over here. There could be three variables or more. So this one goes to 0 because it's got a constant times a constant. Y is a constant. This y is a constant. 5 is a constant. Just pretend those are in front here. They're so the coefficients. So bring this forward. Multiply by 2 and subtract. So it'd be a 10. 2 times 5 is 10. And subtract 1 from the 2 here. That stays x. And the y squared is constant, so it's not by itself, so it doesn't go to 0. You get this. Remember, we're finding the second partial derivatives. So I'll use this notation again. So I know that, and then I take it again. Just like y double prime means the second derivative. If you have y, you compute it. That's the first derivative. And you compute it again, you get double prime. So now I look at this one now. Because see the derivative with respect to x, I have z sub x now. Y is a variable. I'm sorry, y is a constant. It is multiplied by a constant. So this is going to go to 0. And for this one here, variable, y squared constant, 10 constant. So this will be 1 times 10 and subtract 1 gives me x to the 0. So this stays 10y squared. So we want to find all the second partial derivatives. That's the first one here, or one of them. Now let's go with the y. Now we want z sub y. Now the x. Okay, now we're taking the derivative with respect to y. So x is now a constant. So just take this x as part of the 3 and go 2 times that is 6x. Subtract 1 from the 2, we get x. We got the y here. The derivative of minus 2y, okay, just a regular derivative there because it doesn't have an x or anything, so there's just be minus 2. The third term here, differentiating partial derivative with respect to y. So we'll go 2 times 5 is 10. Still got the x squared. And go here, we multiply by the 2 and then subtract the 1, so we get this. So you get 6xy minus 2 plus 10x squared y. Okay? That's the first partial with respect to y. You want the second one. Okay, z sub y and y. Take the derivative of this with respect to y. So this 6x then would be constant. So it's 1 times the 6x will give us a 6x. Subtract 1 from the exponent will give me y to the 0. That's 1. Minus 2 is constant, so that cancels out when I take the derivative. X squared is constant, so this 10x squared is constant, so it's just 1 times that. Gives me a plus 10 x squared. So the second partial here with respect to y is 6x plus 10x squared. Those are the second partials with respect to y and x, but there's also a mixed partial. So now we define z sub x, y. So we're going to go back to this one over here. There's z sub x. We want z sub xy. So that means you have to take the derivative of this expression here with respect to y. So let's just look at it here. And then with the y there, x again here is a constant. So it'll be 2 times 3 there. That'll give me a 6y. Subtract 1 from the 2. Standard derivative there. And then again here, the 10x is constant. Y is the variable, so go 2 times 10x is constant, so it's 2 times 10x is plus 20 xy. Z sub xy is equal to 6y plus 20xy. Now we want z, the reverse of this one, z sub y, x. So we go to this one right here. We have the z, y. Now take the derivative with respect to x. That'll give me the last second partial. So for this one with respect to x, the y now is constant. So this will be 1 times that, subtract 1, gives me x to the 0, which is 1. So this will just give me 6y. The minus 2, again, is 0 because that's constant. Then here, the y is constant in the last term, so 2 times 10 is 20, subtract 1, that'll be 20xy. So if you have a function of two variables, in this case x and y, then we have the two second partials, x, z sub xy, or z sub xx, z sub yy, And then we have a mixed partial, z sub xy and z sub yx. Notice though, they're the same. 6y here, 20xy, 6y for the second one, plus 20xy. Now those are normally going to be the same when you're finding the mixed partials of xy, z sub xy or z sub yx. One condition that the functions have to be continuous. But when you're dealing with polynomial type terms here, x and y and so forth, and y squared, that's always going to be the case. So you can expect these two to be equal. Now we need to find z sub xy evaluated at minus 1 and 2, comma 2. Let's plug it in there. First term is 6y, and the ordered pair here, the y is 2. So this will be 12 plus x is minus 1, so that's minus 20. And then the y is 2. So we got 12 minus 40. Gives me minus 28. So there you have it. Partial derivatives. And that's what the name implies, is that of course you're taking the derivative with respect to one variable and the other one is held constant. So if you're taking the derivative with respect to x, y is constant. If you're taking the derivative with respect to y, the other variable is constant, or the other two variables are constant, depending on whether you have a function of two variables or three variables. Same formulas. You can still have something like this. You can have something like, say, x plus 2y to the, say, 10th power. Say, find the partial derivative with respect, let's call this z. So, and then we say we want to find the partial with respect to x. Then you would say, okay, partial with respect to x here, got x and a y, but the x then is a variable. The y is a constant. So this would go like this. We're going to use the general power rule. 10 comes out in front. We get 10. Subtract 10, we get 9. And then we keep this for now, x plus 2y. And then we have to use the chain rule. Same formulas, except you just have to keep in mind that if you're taking the derivative with respect to, say in this case, x, just treat the y like a constant. So in this case, now, using the chain rule, we've got to take the derivative of this. So the derivative of x, okay, that's the variable, is 1, so it'll be times 1 here, because the derivative of 2y is 0. So when you compute the derivative of this expression with respect to x, the 2y would be 0, the x would be 1. So basically you get 10 times x plus 2y to the 9th. Videos, we'll have a few more videos dealing with partial derivatives and some of the applications. Thanks for watching. We'll see you next time.